In this episode, we'll look at MongoEngine's FileField. In this episode covering FileField, and in the next episode covering the sequential field, I'm going to put some disclaimers at the very beginning, because although MongoDB does store files, that's what part of its functionality, that's not what it's good at. It's good at JSON document storage and queries and indexing. It's a really good database for a document model. It's not necessarily a good file system. It works, and if it's low volume or not worried about the characteristics of the server, then shoot, go for it. In fact, I use it on occasion when it's a small number of files, it's a system that doesn't work with a cluster. I'm not necessarily going to go through all the bother of setting it up with a file system like some of these alternatives here. An FTP system, that's old school. Various cloud services like Amazon S3, Google Drive, and lots of cloud services out there nowadays, or using various localized NAS technologies. So disclaimers out of the way, if you're going to use MongoDB's GridFS system for storing files, let's take a look at the file field. When GridFS stores files, it has some inherent characteristics it keeps with these files. Now, it's not open-ended like a JSON document. It's very specifically these fields right here. You store the length of the file, the chunk size, which is how big each subfile is chunked into. We're going to take a look at what that means here in a moment. The upload date of when it was sent, an MD5 hash of the file as a whole for verifying contents, file name, content type, which uses the same format you would expect to see in web documents, aliases for the file, and of course metadata, which is an open-ended field. In fact, if you're going to store a bunch of stuff in metadata, you just create a dictionary in there and have a bunch of fields in there. So we're back with our famous quote document we've used in the rest of this series. We're importing MongoEngine, going to the famous quote class made out of a document. And I already have my text string, which is where I put the quote, and I'm connecting to the database. I'm not doing anything else in here today because I'm going to do most of this stuff interactively in the shell, so this is just going to get us connected. But let's go ahead and add a file field to this document. So let's say we wanted to put some other notes attached to a famous quote. So me.fileField. It's as simple as that. Okay, let's run this and connect to the database. Let's create a quote document. Famous quote and text. The ever famous hello world. Quote. And let's go ahead and add a file to this. So quote.other notes. Whoops. And in fact, I don't put an equals here. You treat a file field differently than you work with the rest. You don't assign anything to a file field. Instead, the file field is automatically created when the document is created, and you actually run various methods against it to do what you want. So in this particular case, let's go and attach a file using the streaming method. So I create a new file. And let's write some data to it. Blah, blah, blah. Now, this by itself will not work correctly because it's a file and it's not a text document or a JSON document. This needs to be sent in binary form. So here in Python 3, I would prefix the string with a B to make it a byte image, not a UTF-8 string. So let's go ahead and send that in. And then we close it to finish the file. And of course, I could write as much stuff as I want to, and it doesn't have to be a string. I don't mean to imply that it should be a string even. You could take any kind of binary blob of any kind and throw it into the write command, and as long as it's iterable as a sequence of bytes of some kind, it's going to send it into the document. Oh, whoops. All right, and of course to actually save it to the database, quote.save. There it is. Let's go ahead and take a look at the file that was actually created. Bring up RoboMongo, which is actually called Robo3T now. So going into my test database, collections, here is famous quote. And here it is. And notice other notes actually only contains the object ID for the file. It doesn't actually contain the file itself. And that's important because you have a limited size you can put into the JSON document. I think it's 16 meg. So the file itself isn't stored in the document. Instead, you'll see there's two new collections created here. One called FS Chunks that actually contains the body of your document, and then FS Files, which contains indexed information about it. Let's go ahead and open this up. Okay, and here are those fields I was describing earlier. So you have an ID for the document. You've got a chunk size, which is how big the individual chunks are. You've got an MD5 hash for the file as a whole, description of its length, and of course we created a really small file, so 14, and then the date in which we update it. Now I could have added more information into the new file command to give it a file name and other information. Really, more often than not, you don't bother because it's in the context of a document. It's only if you're trying to treat this as some kind of file storage service that you'd give it a name. Or you'd keep that name, say you're accepting an upload from a user. You might create a file name so that the person that uploaded it can reference the original file name. But you can use it for various things. It is in the end simply a string field associated with the file. It actually has no inherent meaning other than it's a descriptive string of the file. And of course, if you go into FS Chunks, you now have a collection of files. We got a binary attachment here, but also you have a files ID, which points to the entry over here in the actual file. And then, of course, this 12EC ID is referenced by our famous quote. Here it is, other notes 12EC. So it's all connected in the database. Okay, now let's do it the more traditional Python-y way. Let's create another quote. Okay, again, we're going to use the methods associated with the file field. So got other notes, dot put, and then we put in a file handle, a Pythonic file handle. In fact, don't do this first. Let me go ahead and create a file handle so we can work it. So FH file handle is open, and I've got a picture on my local hard drive. We'll go ahead and upload that. So clouds.jpg, I believe is right. Let me verify. Yep, there it is. So I need to open it. So it's a read operation. And I need it again as a binary byte image and nothing else, so RB. Now I've got my file handle. Now it's not read in the file yet. In fact, if I were to do a fh.read, for example, I will pull in the whole file and try to display it on my screen, which won't work because it will be in binary format. It'll look like a mess. But let's go ahead and add that to my quote now. So quote dot other notes dot put a file handle. Now if I do quote dot save, it'll save it. Now because the file handle is just a pointer to that file, it opens it up but it doesn't do anything with it yet. Until I press enter here and actually save it, it's not going to actually read the file. So this is a late binding. It's going to pull it and actually save it all in one operation. So quote.save, now it's saved, and let's go back and take a look at it in our collection here. Here's a new entry, gung ho, and again it's created a new file index, and it's made a whole bunch of chunks now. And here it is, a whole bunch of chunks in order to save that one file. And going back to going back here, going to the index, notice it didn't save the file name. Now I can pass it the file name. In fact, let's go ahead and do that. I'm going to rerun this script. Okay, I did it again. So I, over here, create another famous quote. Actually use the same text, gung-ho again. That's going to be confusing. Now, I didn't make a new file handle since I already had one. I just seeked it back to the beginning of the file again. We're going to actually go through and do that again, actually with MongoDB itself. There's some cool tricks you can do with this. And then in quote.othernotes put, and then this time I passed in the metadata. So here's some actual metadata, and then here's a file name I gave it. I actually could have called this anything, but be consistent, I called it clouds.jpg, and I saved it. Now if I go back and look at the documents on the MongoDB server, let's go ahead and refresh this. Now I can see I have the file name stored, and I've got some metadata, which is A to B. Let's go pull our original document we created with the hello world in it. So let's find the quote. I'll just call it Q equals famous quote dot objects where text equals hello world first. Okay, if I do Q, we see we have our famous quote object. So Q dot other notes. By itself, I'll just get a proxy. This is essentially an internal way of proxying up to the MongoDB server. It hasn't actually done anything yet. It has not pulled in the notes. So if I want to see those notes, I Q dot other notes. Read. And there it is. I've got a binary image back of what was in there. Now notice I didn't do that with the actual picture, because if I did that, it probably crashed my shell, because it'd try to print out an image document. That's not too useful. Well, what I would have done actually if I was going to do that is save it in a variable and then resend that somewhere else. So if I do and then, of course, whoops. Oh, actually, that didn't work. And here's why. And here's where we're going to get into some of the fanciness you can do. The reason I didn't read anything is because I was already at the end of the file. In fact, I can do this, q.othernotes.tell, and this will tell you where you're at in the file at the moment with the file pointer. So I'm at position 14, which is at the end of the file. So if I do q.othernotes.seek 0, I can now read it again, so now I can put it into the variable. And let's say I only want to read 4 of the characters. So I can type in size equals 4. Now I'll read 4 of the characters from our file, or 4 of the bytes from our file. I keep saying characters, it's bytes, it's not a string. So if I look at V, I've got the first 4 characters. Now, this is actually very useful if you're working with really, really large files. But again, get back to my original discussion, you probably don't want to do this too much with really big files. But having said all that, if you want to, say, attach to a file on MongoDB and look deep into the file, let's say 50 meg into the file and only read 4K at that 50 meg position, you can use the seek commands to only pull in the limited amount of information you're actually trying to get out. So I could have started from anywhere. So if I typed in q.seek 10, oops, q dot other notes dot seek 10. I'll only read to the end. Actually, would have done a size. That's probably a better way to do it. And it read to the end by not putting in a size. But you can see how you can actually now very specifically go to different sections of the file and read just portions of it. Now, with this, we also have some additional methods we want, because you want to be able to not just read and write to files, you'll also want to be able to delete them. So q.othernotes.delete will do just that. It'll actually delete the file off the Mongo database once I save it. q.othernotes. Yeah, don't just do the methods. You have to do a save if you want it to actually save. Save. Okay, now it's saved, and it no longer has the file stored in the FS collection, and it no longer has the ID. In fact, let's go ahead and take a look at it. Getting back to here's the hello world, and notice that the file field is now missing because you've deleted the file, as well as the reference to that file. Now, you might ask yourself, wait a minute, what if I have multiple documents or some external system pointing to that object ID? What will happen if the file is missing, but I expect it to see it there? Well, if you do that, you'll get a none response back from MongoEngine. So q.othernotes, that returned a none. In fact, to see that, or so receiving a none means the file is missing or not accessible in some way, shape, or form. We can also replace a file. So let's go ahead and pull in one of the other documents that had a picture attached. And let's take a look at, and let's replace that with, and actually I'm going to show you a trick here. Because open statement in Python returns a file handle, and the replace statement, as well as the put statement and a lot of the other statements, expect a file handle as its parameter. You can actually just embed the open statement right into the command. So open rm ipsum.text. Oh, whoops. RB. There we go. Of course, nothing has happened yet until we save. And so if I take a look at it and try to read it, we've got the standard lorem ipsum document in binary form. Okay, that's the basics of the file field. Now there is a related field to FileField called ImageField, where it does a little bit of extra trickery for you. Let's go ahead and use it. Let's see, icon. me.ImageField. Now, used as you're seeing here, it's really not any different than the file field. However, if you pass in size parameters, you can pass in size and thumbnail size, it will actually resize the image when it's storing the document at the same time. Now, for this to work, you do need the PIL library for Python, and it's not part of the pip install by default. You have to have it already installed. So size equals, there are 3 items in the tuple that needs to be passed into both size and thumbnail size. And in that tuple, you will pass the horizontal, the vertical, size that you want for the image, and whether the image should be manipulated to make it match that size, or whether it should allow it to freeform on one of the two parameters. So, for example, if you have a square image here and you try to make it a 400 by 200 image, if it's set to true, the final image will be 400 by 200. If it's set to false, it will probably be a 200 by 200 image, because it will minimize it until it fits one of those two parameters, 400 or 200. And let's go ahead and make this false. And then let's go ahead and make a thumbnail, but I want the thumbnail to be forced into the right size so it works in my web page or whatever. So 20 by 20 true. Okay, let's go ahead and use this. So we want to do a put, and we'll pass it in a file handle to clouds.jpg. And let's save it. Okay, let's take a look at this in the actual database, because if ImageField does do one kind of crazy thing, and if it's not self-evident, it's certainly not documented, which will drive you nuts, trying to find out what it's doing, especially if we're in a large database that has a lot of collections in it. It might get kind of lost in the noise of what it's doing. But here I've got a nice small database. You'll notice here I've created 3 files already. Where's my 4th file? Where's my image? Where's it stored? In fact, I should have 2 files somewhere, right? I've got a original file and a thumbnail file. It's not there. Well, here, let me refresh my list of collections. You'll find, oh, there's 2 new collections here. And whereas GridFS is by default designed to be stored under FS, now suddenly there's 2 new ones. And in fact, if you look under here, there is now a new file, in images.files, which is a completely different non-standard collection, and it has new information in. It's got the format that is a JPEG document. It's got a thumbnail ID, which references another file. So there's one entry in files to represent both files, both the original resized image as well as the thumbnail image. So here we've got, here's the original ID here. Oops. So I should have a chunk for this file ID. I should have a chunk for, actually this shows null. That's odd. Oh, here's why it's missing. You put asked in the wrong parameter. I wonder why it didn't give me an error of some kind. So thumbnail size. Okay, that makes sense. Let me save this and run that again. Okay, now it's working. So I have a object ID in here that again has the format and has a thumbnail ID, which is referencing ED3, which has another entry in the same document of ED3. Again, a JPEG and a width and height that's different than the original width and height. So here it is. It's resized my 400 to a 400 by 200 image, but as you can see here, I didn't actually go to 400 because I didn't tell it to force the size. So I passed in a false value for the original document. So it minimized it down to 200, and so that these both fit within a 400 by 200 image. And then the icon, the thumbnail, excuse me, is actually forced to 200 by 200. And of course, it's a much smaller document, 708 bytes as opposed to 11,046 bytes. So there we go. That's the kind of the workaround they've done in order to make this all work. Maybe if I get time, I'll do a pull request to put this into the documentation on MongoEngine. Okay, and then lastly, I want to show you 3 fields that are mentioned in the API documentation that seem to be about the file field. There's a GridFS proxy, GridFS error, and image GridFS proxy. These are essentially the internal classes that are used by the field when you actually create an instance of the document. In other words, they're internal procedures. I'm not entirely sure why they're in the API documentation. I don't recommend you use them unless you really know what you're doing. These are not meant to be put into the document class. So yes, they're in the list of fields. Technically, you will see them when you're taking a look at what the file field or the image field becomes after the documents is instanced, so you can actually find out. But it doesn't actually say that in any clear or useful manner here. So just kind of a catch-all. Don't use these unless you have a very specific need that you know precisely what you're doing. They're actually internal classes used by MongoEngine, and you probably should just ignore them. Okay, that does it for this episode. Next episode, we'll do sequential fields. If you like what you see, please subscribe. Thank you.